Welcome everyone. We're going to wait 1 minute to have attendees join the webinar, and then we'll be beginning soon. Welcome everyone. We are going to get started. My name is Caitlin Haas-Conrad, and I am the Assistant Director for Partnerships at the Wilton E. Scott Institute for Energy Innovation at Carnegie Mellon University. I'm excited and grateful to welcome all of you to today's Renewable Natural Gas webinar. This webinar is a collaboration between the Wilton E. Scott Institute for Energy Innovation at Carnegie Mellon and the Center for Sustainable Business at the University of Pittsburgh. Here is some information on different ways you can connect with the Scott Institute. We are an institute at Carnegie Mellon University in Pittsburgh, Pennsylvania. We've been around since 2012, and we are among the top 10 university energy institutes in the country, according to the American Energy Society. We see ourselves as a hub in a national energy and innovation ecosystem. We work with government organizations, venture capitalists, startups, and philanthropic organizations. The Institute has 5 areas of focus: collaborative research supporting over 160 faculty members at Carnegie Mellon University, strategic partnerships, policy outreach, entrepreneurship, and education. In our day-to-day operations, we support faculty and student research, engage with industry and in the public sector. We form strategic partnerships. We host energy initiatives and events like this one throughout the year, with our biggest event being Energy Week, which happens in March of every year, which usually has over 1,000 participants. And we foster entrepreneurship on campus with our partners. I'd like to invite everyone to our next virtual event as well, which is taking place next week on Wednesday, April 27th. Jay Hakes will be giving a special presentation from the University Energy Institute Collaborative Summit in Golden, Colorado, and we're giving special access to this distinguished lecture virtually. Jay is a presidential and energy historian, author, and former administrator of the United States Energy Information Administration, and is a very engaging speaker that we're very excited to be one of the main attractions at the summit. You can register for the event using the QR code you see on the screen now, or you can sign up in the link that will be shared in the chat today, and we hope you can join us. Now I'd like to introduce you to today's moderator. Chris Gassman is the Associate Director of the Center for Sustainable Business, a leading business strategy collaboration hub at the University of Pittsburgh, partnering with companies like Dick's Sporting Goods and PPG, as well as thought leaders like Lisa Ross and Paul Pullman. Chris previously worked as the Chief Commercialization Officer of a service-disabled, veteran-owned small business tackling climate, modern slavery, and innovation. He is a social entrepreneur with a decade of experience in the US, Egypt, Germany, China, and beyond, helping companies thrive. He hosts interviews with CEOs about doing well by doing good on the Market and the Good podcast. Before I hand it over to Chris, during the webinar today, if you have questions, please type them into the Q&A feature. I'll be asking panelists questions from the attendees after the presentation. Thank you, Chris, and I'll hand it off to you.
Awesome. Thank you, Caitlin, and excited to be here in collaboration with the Scott Institute. I would be remiss if I didn't mention for the audience that we also have an event coming up tomorrow at noon Eastern that will continue on this conversation from a variety of perspectives. So you've all probably seen the SEC and ISSC efforts that have come out recently. We're going to aim at what's the 5% that people aren't talking about. that everyone should really know about. So we'll have folks from Ceres. We'll also have folks from Project Drawdown, who I know have been featured by the Scott Institute previously. So it should be a good crew to have them both in the event at the same time, as well as an alum from Carnegie Mellon that's been picked up by Breakthrough Ventures. So should be a very exciting conversation tomorrow. If you want to keep digging into decarbonization, I encourage you all to join. And I believe the link will get shared in the chat as well. So whether QR code or link, we'd love to have you there tomorrow. With that, love to turn to today's conversation around renewable natural gas. So we've tried to get a inclusively diverse group of folks in the conversation today. And you all have plenty about their bio already online that you've seen in advance. So I want to save our precious airtime together for each of them to share a bit more, about their personal journey, their perspective, and their brief, 30-second, 90-second intro for what brings them to renewable energy, or what are they really seeing as the big trends in the renewable energy space here as we look forward over the years. So love that is already lined up. It saves me from trying to figure out how to go through on Zoom. So in our Zoom chairs, Marc, if you want to start us off with what brings you to renewable natural gas.
Yeah, thank you, Chris. So I got into this more by chance than anything, but ultimately, foundationally, this is really a lifelong passion. I've been in big industry, working all across the globe for decades. Worked in Europe, Asia, mainly for large chemical companies, and was a massive consumer of energy in the form of natural gas, electricity, and other things. So I had a business here in South Carolina. Heavy utility use, a couple examples, 6 million gallons of water a day was nothing to us. We would burn 20,000 gallons of diesel oil overnight to run our boilers, and quickly sort of realized that there's a huge opportunity to connect agriculture and industry by harvesting fugitive methane that is just oozing out of lots of different places, and quickly got into it. I'm sort of an entrepreneur by nature, and started a business called GreenGasUSA 3 years ago. And since then, we've started to produce renewable natural gas from agricultural sources. We're mainly in large food waste, so things important to all of us from a food security standpoint. And if we do want to feed the world, kind of unavoidable, but there's a ton of methane that just oozes from these processes, and we capture it and we use it to displace fossil fuels with the likes of Duke University, Berkshire Hathaway, the Mercedes-Benz plant here in Charleston that makes Sprinter vans that if you're on Amazon, you see them a couple times a day probably. We've converted their paint booth to renewable natural gas. So it's been a super fun journey, a lot of learning, extremely humbling, but just something we can all do together to make an impact in the world and reduce what, from an educational standpoint, we all just need to accept is one of the most potent greenhouse gases out there, and that is methane. So I look forward to talking with you all about that today and getting everybody's thoughts.
Perfect. Thanks, Marc. And it looks like, Sharon, you are the next one up in my Zoom cubes. So do you want to share a bit about what brings you to renewable natural gas? Sorry, Sharon, we can't hear you. You're on mute. And while, oh, there we go.
I'm sorry, can you hear me now?
Yep, there we go.
Okay, good afternoon, and thank you for having me. What brings me here is my background. I started out in the energy field. I worked for Duquesne Light company here in Pittsburgh, Pennsylvania for 24 years, and very much interested in the energy field. I came to Montauk as a part of their landfill gas business. Started out with Montauk when they were a subsidiary of Duquesne Light Company. And they started out in the landfill gas recovery industry. So that became very much a passion and an interest to me. And then Montauk went off and became separate from the energy company here, the utility. So I started to work for Montauk Energy at the time. It's now called Montauk Renewables. It is on the NASDAQ. We are a publicly listed company now, which is also exciting. what brings me to this space is really the passion for the environment. Renewable energy in general is very important, I believe, to this country, to our future growth. And definitely it is a solution for the greenhouse gas climate issues that actually we're facing globally. Renewable natural gas is important because it is a carbon neutral solution for fossil carbon, and used in the regulatory schemes that there are out there now. The renewable fuel standard, the EPA's renewable fuel standard, and programs such as the California low carbon fuel standard. They have been very successful in bringing renewable natural gas developers to this space because they have been successful in reducing the carbon footprint, especially with regards to transportation. So that is my interest, and that is what Montauk does. We are a renewable natural gas developer, and glad to talk about this issue today. Thanks.
Brilliant. Thank you, Sharon. And I don't know if Zoom, how it thought of it, but Sam, you happen to be the next one in my queue. So that seems to be a good build based on our initial two panelists. So why don't you share what brings you to the renewable natural gas conversation?
Sure, thanks, Chris. So when I was, growing up, since I was a kid in college, always had an interest in working in the environmental field. And that sort of led me to, wanting to work on climate and energy policy. My first job out of college was actually with Sharon at Montauk. So that's how I got involved in the RNG space, and just really got excited about, the prospect of reducing methane emissions, providing a real solution to improve the way that organic waste is managed on a large scale in the US, and providing a clean fuel that can substitute in for geologic gas. So that really led me to sort of stay in the field. And I think, we're seeing a lot of growth. It's really exciting. And again, just the prospect of being sort of a triple win solution for the environment really is attractive to me. So that's why I'm here, and that's why we're doing what we're doing.
Brilliant. Thank you, Sam. While we have kind of circled back to being local, looks like Zoom has us going back out to far again. Larry, you are the next one up in my queue, and you might be our farthest panelist geographically. But appreciate you joining the conversation, and please do share your journey with RNG.
Yeah, thanks, Chris. Yeah, I'm from Calgary. We had a big dump of snow last night, so we're still enjoying winter, even though it's supposed to be spring. I've been in the oil and gas business my entire career, worked with many major organizations, companies, many of them US based as well, developing, working with geologists and geophysicists, exploring for resources, producing them. Economics were always a big part of this. And for the last 10 years or so, I was in R&D, looking at better ways of getting gas out of the subsurface, like off oceans, shale gas, bitumen as well, doing oil sands recovery. And then for the last few years, I've been working with PTAC, which is a not-for-profit. There's about 7 employees, and they do a lot of environmental research stuff, water, air, ecology, counting grizzly bears, looking at habitats for birds, and reclamation, abandonments, and air is a big part of it now too. For the last 10 years, we've been looking at methane emissions. The government of Canada has come up with regulations that require oil and gas companies to reduce their emissions. So we've been working with many companies. There's 250 members, I think, in PTAC, and this one consortium that we're working on has about 16 producers and about 16 or 17 researchers from across the country, and 2 actually from the States, where we're looking to find technologies which will capture methane that would normally be emitted through pneumatics or tanks or whatever, and capture that and put it back into sails, or you actually combust it. So when you were saying your thing that we're coming from a diverse backgrounds, I agree with that. We're diverse backgrounds, but common goal, right? The same end goal that we're looking for. So thanks, looking forward to being here.
Yeah, no, appreciate it. And circling us all the way back to Pittsburgh, just probably a building or two away from me. Professor, why don't you bring us on? What brings you to the RNG space?
Yeah, thanks, Chris. Again, I'm leading a research group at the University of Pittsburgh focused on catalytic reaction engineering, process intensification. So basically, we look at the next generation intensified processes for the chemical industry over a broad range of applications, going all the way from natural gas, hydrogen production to the specialty chemicals industry, with the idea of really developing technologies that have a much reduced energy demand and much lower environmental and physical footprint, in particular applications also to decentralized modular processing of resources. I'm passionate, of course, as somebody in academia about not just developing technologies, but also, again, training and developing the next generation of engineers who will help us in this transition. And overall, I've always been fascinated at with the interface between basically fossil energies and the emerging renewable energy solutions. And of course, renewable natural gas is sitting right smack in that space in between, and can really bridge between those two worlds that are ultimately the same world, right? It's the one world that we all live in and where we have to make a difference.
Brilliant, thank you. And with that, now we got the panel here with us, and we've used the word either in acronym form, RNG, or in full form. I would be remiss between multiple academic institutions if we didn't at least have a definition in there. So I don't know if there's a group among the panelists. I know, Sam, you're well placed for it, but feel free for any. What have you found has been the best way to describe or define that that we should share with the audience, just so we have a level set?
Sure, thanks, Chris. I can take this one. So I think generally speaking, in the industry, we define RNG as biogas, which is captured from landfills, wastewater treatment plants, agricultural operations, and increasingly dedicated anaerobic digesters, which better process that waste. The biogas is taken from those resources, then cleaned to pipeline quality. So that's how it can be then used as a substitute for conventional natural gas. And it's a carbon neutral fuel when combusted, just like many other bioenergy resources.
Gotcha. Thank you. And I think that gets us right into one of the next questions that we had. So Sam, you started teeing up there some of those environmental benefits. So in folks' experience, what are the ways, how are those environmental benefits verified?
Before we go on, Chris, I'd like to interject about the definition of renewable natural gas. Is it more methane that would normally be emitted into the atmosphere that we're trying to capture? Would that be broader, Sam? Because by claiming it as just biogas, that makes it, that includes methane from oil and gas companies, does it not?
No, actually. So biogas is derived from biologic or biogenic carbon. So basically the process behind it is that, when you consume a food, whether it's a human consuming that food or animal consuming that food, or when we produce any type of organic waste in our society, that material was ultimately derived from atmospheric carbon. So as that atmospheric carbon is sequestered in the growing process of that organic material, and then re-released into the atmosphere, it's actually a 1-for-1 carbon cycle process. So in that sense, the carbon contained in biogas is biogenic, it's biologically derived, it's taken from the atmosphere. Whereas the difference between that and a fossil fuel, right, is that it comes from under the ground. So there's sort of a time span thing there if you want to get deep into like the academia of carbon accounting, right, millions of years. But generally speaking, the delineation is that biogas comes from existing atmospheric carbon that would be currently part of the atmospheric load, whereas other geologic carbon resources would not, and therefore would add to the carbon load in the atmosphere currently, contributing to climate change.
Well, geological carbon is also made from mostly algae. So it's, like you said, it's the time cycle then. It's gas that's been sequestered for quite a long time versus gas that's new. So your definition of biogas is more recent gas. You're looking at recently created gas versus gas that was made a long time ago, because they're both biologically sourced.
And gas that's in
Sure,
the
yeah, I
ground.
would. Go
I
ahead,
think we
Sharon.
can move on then. Chris, sorry.
I was just going to say, I mean, with regards to timing, it is in the current carbon cycle, which is important, which is, you know, what we're looking at.
Yeah, but then if we do timing, then you can go, well, gas that's leaking out of a compressor, be it compressing gas from a biological source, a short-term one, or gas that's been in the ground for a long time. And the compressor is designed to slip methane past the cylinders. Otherwise, it would be a solid piece of steel. So gas that's slipping past that compressor that was sourced from new gas is still a new gas leak versus gas that's slipping through a compressor from old gas is still old gas. But either way, it's gas that would be emitted into the current carbon cycle versus gas that's been sequestered for a long time.
Thanks, Larry. And I've included in the chat a link to EPA's definition for renewable natural gas, which should be helpful just in sort of level setting on these terms. And respectfully, I do think it is important to delineate strongly the difference between a biogas and a geologic gas.
Yeah. And Larry, I think your point is going to foreshadow for a further conversation of, you know, regardless of the source, you know, what about the infrastructure? Before getting to that piece, you know, one thing that we were talking about is, okay, hey, great, you know, we're making these various environmental benefits claims for those in the business, in the space. What are the processes that you go through that you have to go through or that you choose to go through to verify, hey, we are actually doing what we're saying we're promising to do?
Chris, I'll take that one. With regards to the production of renewable natural gas, if you participate in the Renewable Fuel Standard, which is a federal program, or a program such as the California Low Carbon Fuel Standard, there are various intensive verification requirements to verify that you are actually producing, you know, renewable natural gas. The first thing with, I guess, going back to your first question, what are the environmental benefits? One of those are, first of all, that methane is approximately 25 times, has the 25 times the global warming potential of CO2, okay? So the capture of methane is very important with regards to the verification of the environmental benefits. So part of that is the EPA's mandatory greenhouse gas reporting program, which landfills participate in and many other industries also participate in. So that's one method of verifying the environmental benefits. So capturing the methane is very important. With regards to the processes that we have to go through, the cleaning up of these gases to get them to pipeline quality, there's many steps where the data is verified by a third-party participant. We have to verify that the gas is actually injected into the pipeline, the existing infrastructure. So we get pipeline statements from the local utility. And then there are audits, quarterly audits by third-party verifiers, as well as annual audits. So there's a lot of verification of the data that actually happens to capture that methane.
Perfect. Thank you, Sharon. And Marc, I don't know if there's anything different on that side from the more agricultural space or from yours, if there are any other verification or efforts that you guys have been participating in that should be of note.
No, Sharon did a great job describing it. We subject ourselves to voluntary audits and we register our carbon claims on carbon registries just so that we can have absolutely verifiable claims. And our voluntary off-takers are very interested in us doing that. So again, if, you know, sort of with more of a global background, these types of regulatory programs, verification programs, they exist in Europe and have existed for decades, and we're lagging a little bit, as we tend to do in the environmental space here in the US. There are great programs to reference that, depending on who your client is, you can choose from any number to verify the claims that you're making and ensure that the carbon that you're sequestering or avoiding is verifiable, and we do that.
Gotcha. Perfect. And while I know that I've got plenty of questions on my side, I want to be mindful and tee up in advance, because I know we're getting to the part of the conversation where we usually have lots of robust questions coming in from the audience. So I do want to encourage folks. I already see at least one coming in there. So do go ahead and use the Q&A function on Zoom. We'll be pulling the questions from there while those keep coming in. And I do appreciate that, and I do love when we actually have candid, constructive conversation. So I like that where it's not just a panel of bobbing heads, that there is actual active discourse here. So this is good. So with that, I know one of the pieces that we touched on earlier was, is this decarbonization? So we can next get to the infrastructure piece, but just from the sourcing of it, from the R&D side, I don't know, Professor, if there are any questions that you still have about whether or not this is decarbonization, or when to think about it, or Larry, from your side, or others on the industry side of like, hey, it is decarbonization when this, and it's not when that.
Yeah, I mean, I think it's a very interesting point to think about whether renewable natural gas is decarbonization. I mean, sort of if you take it sort of from the really technical perspective, of course, you're not decarbonizing. The carbon isn't removed. You turn carbon from one form to another form. But as Sharon said, of course, the global warming potential of methane is much higher than for CO2, at least over the 100-year time frame, about 30 times higher. Now, one could, of course, also argue that we're basically kicking the buck down the road, right? We're basically creating CO2 emissions that in the long term are in the atmosphere. The lifetime of methane in the atmosphere is about 12 years. For CO2 is anywhere between 300 and 1,000 years. Certainly it has strong near-term benefits to capture those methane emissions and use it then for combustion. For the longer term, again, sort of the jury is out in the bigger transition that we have ahead of us. One concern that I have with that, I mean, again, in order to get, for example, the renewable fuel standard credits, of course, you have to turn it into a transportation fuel. And that means that you're now taking relatively concentrated, localized emissions and turn them into dilute, widely distributed emissions, right? So while one would have the opportunity to capture the carbon actually as it's emitted from the landfill or the agricultural site, it's basically impossible to capture the emissions from vehicles that are driving around. So I think it's really, one has to look very, very carefully at the use of the renewable natural gas. Also, where does it replace the use of conventional natural gas, or does it maybe slow down a transition to a deeper decarbonization via electrification? So the whole life cycle analysis and the analysis in the context of whatever regulatory or policy developments are targeted may come to very different answers on whether this is truly decarbonization.
Thanks, Professor. I think that's a lot of really good points there. I agree with most of what you said. I think one thing we really need to level set on in this conversation, right, about why RNG is decarbonization, it's not just the methane destruction. So again, the difference between renewable natural gas and geologic natural gas is that RNG is comprised of biogenic methane, which contains carbon that was sequestered from the atmosphere via the growth of organic material and is already part of the existing carbon cycle. So it's extremely important to remember that we're not adding carbon to the atmosphere when we're combusting RNG. It's carbon that was already sequestered from the atmosphere. So this concept is substantiated by all major greenhouse gas accounting bodies. That includes the Intergovernmental Panel on Climate Change, World Resources Institute, US EPA, and others. So, I mean, this is long settled science surrounding the use of biofuels. And really that's why RNG is such an important resource, right? Because it's a clean fuel, which can be blended into the gas network to reduce carbon intensity now. And as we move away from fossil fuel use, these clean fuels will still be valuable in the long term for certain applications.
I completely agree. But again, what this means is effectively that at best, these fuels are carbon neutral, right? I mean, of course, overall, they're not carbon neutral because I have to put energy into the processing of the fuel. And unless that energy comes now, again, from renewable and clean sources, there is, again, the question, what's the carbon footprint on that end? But overall, it is carbon neutral, certainly, as you said. It is ultimately atmospheric carbon that is being used here. There is the question of timescales, of course. I mean, it takes a lot longer to sequester that CO2 into the plant growth than to combust it at the end. But the coming back to the question, is it decarbonization? I mean, as long as I'm carbon neutral, I'm not really decarbonizing unless that carbon neutral fuel is replacing fossil fuel that would otherwise add new carbon to the atmosphere. So again, it really depends on what's the impact of RNG, where is it going to be used? As long as we replace fossil fuels with renewable natural gas, I completely agree. There is no question that that is a big step forward towards mitigating climate change effects and decarbonizing.
I think there's still a concern with the definition of RNG. I think a methane molecule, no matter where it's sourced from, whether it be geological, swamps, agriculture waste, stuff from garbage dumps, wherever it's sourced from, it doesn't matter. Once a methane molecule gets into the atmosphere, it's got the same result as any other methane molecule. So to differentiate between the source of one doesn't really get us anywhere here, I don't think. But the technologies are certainly common across all of the different sources. Like we need compression, we need dehydration, we need to have all these things to make sure that the methane is a valuable product down the line to the consumer. So I don't think it matters where it's sourced from, and to classify one as, you know, this is RNG, this molecule is really special, and this one is a fossil fuel one that leaked into the atmosphere, and we don't have to care about that one. That to me is a differentiation that I don't think is helping this conversation. But if the decarbonization, we start with a methane, like a carbon molecule, and it ends up being a carbon molecule. So Professor Veser is quite correct that we're not decarbonizing, but we're deloading, right? Because of the methane potential versus CO2 potential. So part of the oil and gas, one of the solutions that exists for oil and gas is combustors, where the natural gas is too low a pressure or something, and it goes through a combustor, which converts 99.95% of the methane to CO2. And that, you know, the oil and gas companies put those on, they're not rewarded for it, but it deloads the atmosphere.
So,
I'm sorry.
Go ahead. If you have a point, because I know that we have a question from the audience that's kind of like right on this that I think might hone us and move us forward in it. But if you have a point on it, no.
Go ahead. I was just going to add on to the use of RNG. Topic of this panel here. Primarily, if you use it for transportation fuel in the programs that I mentioned, the Renewable Fuel Standard, as well as the California Low Carbon Fuel Standard program, it is decarbonization, because it is replacing one for one either gasoline or diesel fuel. And in that pool, the RNG is playing a very critical part of decarbonization. And those programs are very successful because they are reducing the carbon footprint. You compare it to diesel, how much carbon that one is, how much CO2 diesel fuel, and then you use RNG as a vehicle, there is a reduction.
So thank you, Sharon. That's actually a brilliant segue to one of the questions that we have from Jordan on, thinking about how do we see RNG fitting into this sustainable energy transition, right? Are there, is it primarily heavy industry and transportation? Like where does it like, hey, this is where we should be prioritizing. We're talking about switching it out one for existing stuff. So what are some specific use cases that the audience should be thinking about for that?
Chris, I'll jump on that one if you don't mind, just from our vantage point. So we deal exclusively outside of the transportation space. A lot of RNG does go into transportation fuels, and that's a wonderful application. But I just wanted to create a little bit of diversity in use here. So our RNG that we produce is used for decarbonization, mainly of utilities and large industrial processes. So what that means, as I said earlier, in the case of Mercedes-Benz, you're using that natural gas to dry a paint booth and then cure the paint on a vehicle. And to the professor's point earlier, this is absolutely displacement of fossil fuel, which would otherwise be the source of energy to achieve that end goal. So we feel really good about driving or filling demand for RNG from industrial utility type customers who otherwise would be combusting fracked natural gas. Another use case is Duke University. So we have a partnership with Duke University whereby they use natural gas to heat their campus, among many other things. And instead of using fossil natural gas, they will be using renewable natural gas to achieve that end goal. So there's a very diverse application set for renewable fuel. And just while I'm speaking here, just want to point out that this is not the end all solution to all of our renewable energy problems. I think we all need to be fully cognizant of that. And we need to say that out loud as representatives of the RNG industry. This is a piece of the puzzle. But if you're a large industrial manufacturer who has hundreds of millions of dollars invested in assets that are currently combusting a fossil fuel, and you're able to transition into a renewable fuel without having to change your assets, that is extremely attractive for those end users, whether that's transitionary or permanent. And I don't think we need to discuss that today, but being able to use renewable natural gas in existing natural gas pipelines, just blending it in, using it in an existing boiler, in an existing paint booth, in an existing heating system for a university, makes its application immediate. And one of the things as an entrepreneur that I get very passionate about is speed. We have to do this with conviction and speed if we're going to make a difference. If we sit around the table for the next 10 years debating the merits of, is it 21 times or 28 times CO2, great. You won't find me at that table. I'll be out there covering lagoons, harvesting the methane, and finding users who are willing to act, who have made commitments. Whether we're going to be doing this in 10 or 20 years, I sure hope so, personally, but that's not a reason not to be very aggressive about these things today and prevent methane from leaking out of landfills, production of fossil fuel systems, or food processing, wastewater treatment, municipal wastewater treatment systems, where there's a lot of it and it's going straight to atmosphere.
Awesome. Those are great comments.
Marc, can I go next on this one? So I think one of the points that Marc made here, which is really important, right, especially in how we talk about RNG, is that it's not a panacea solution, right? So a lot of the criticism that the industry gets is that we can't replace all of the existing gas demand with RNG. And that's absolutely true, right? But the amount that we can replace, even if that's only 10%, we think it's more than that. But, conservative estimate, 10 to 13%, that's still a very substantial amount of existing gas demand. And I think the way to think about this, right, is that now, given the vast gas network that exists, we can start blending these clean fuels, RNG and clean hydrogen, into the gas network to decarbonize. That goes beyond the transportation sector. It goes into any end uses which currently use natural gas. And then in the long term, as the gas system is scaled down to prevent more burning of geologic gas, and as more things are electrified, we can address more targeted end uses which need clean fuels or which have reliability benefits with fuels like RNG and green hydrogen. So I think generally speaking, that's how the industry views it, and that's how we approach it from a policy perspective from the Industry Trade Association.
Yeah, excellent. I
agree
think
more.
sorry.
Go ahead, Larry.
The oil and gas industry is certainly, set up to be able to handle RNG coming into the system, and I think that's the awesome way to do it. It doesn't, that way you're not reduplicating infrastructure and stuff like that, all that spending. So that's perfect. I really liked your comments there, you guys. If I could just take Susan Power's question here about, she's disappointed with flaring of methane. The alternative is to just release it. There's a whole bunch of stuff at oil and gas facilities that are required to keep the operations safe. And some of them, like slippage through a compressor that I was talking about. If you're compressing natural gas, it slips through just in order for the machine to run. If you made it solid, it's not a machine and it would no longer compress natural gas. So by engineering, that's how the machine works. Now, if you collect that little bit of methane, it may not be, now you have to take that at atmospheric pressure and compress it all the way back up into the pipeline. Now that's not economic. You have such a low volume of natural gas, compressing it a whole bunch of times to get it back into the pipeline doesn't make sense. So that's why things like combustors come in. Now, combustors aren't cheap. They'll cost you some money, but the alternative is just to vent the methane. So we're looking at combustors where it's not economic to get that methane, and we combust it back into CO2 so that it's not being vented as methane into the atmosphere. So it's an alternative to just being venting. That's why combustors come in. So yeah, I agree that there's an economic heating value. Another thing that's done if the operations are remote is if there's enough natural gas being available, it'll be running like generators that'll run computer systems that are mining Bitcoin, for instance. So people at a remote site that don't have any electricity will burn their methane to convert to power to generate, to burn into a generator that uses computers to mine Bitcoin, and then they're connected to satellites. And so the methane is being used to mine Bitcoin, and then it takes the load off of electricity systems where it's already hooked up to people's homes and stuff like that. So there's a whole bunch of different solutions for using the natural gas, and we try to use it, well, not me, but oil and gas companies try to make maximum use and value out of the stuff. And certainly combusting it is kind of a last ditch effort, but it does convert methane into CO2. And actually that could be used for dumps or manure piles or whatever as well. If it's too much money to connect that to a system, to get the oxygen out, to get it dehydrated, make it pipeline spec. If that's not possible, we could combust that gas as well. So combustors are good for any methane, no matter what the source is.
Veser, I know that you had a point in there as well.
Yeah, I just wanted to also sort of pick up Marc's comments, which and Sam's, which I perfectly agree with. Sort of just keeping in mind that for decarbonization, we basically have two goals, right? We need to decarbonize deeply, but we also need to do this quickly. And I think renewable natural gas has an important role in the quickly part, more so than in the deeply part. As Marc was talking to, again, we have the assets on the ground. It's a drop-in fuel for current fossil natural gas. So this is a really quick approach to reduce the climate impacts of fossil fuels by replacing existing fossil fuels with a renewable fuel. And maybe very briefly to Larry's point also about flaring of natural gas and the question in the Q&A. Again, I mean, if very typically gas is flared in as so-called stranded assets, right? They're somewhere in remote locations where you simply can't utilize them well. And what people often don't realize, I mean, building a natural gas pipeline, that costs about $10 million per mile of pipeline. Aside from the fact that, of course, most people don't want to have that pipeline run in their backyard either. So the challenge then really is exactly like Larry said. I mean, I can combust it and at least get some energy value out of that and turn the much more severe greenhouse gas methane into CO2. What I would love to see more is, and what my group is also working on, are again small decentralized units that would allow us to turn those stranded natural gas assets into higher value liquid products on location. And of course, the liquid is 1,000 times more dense than the gas. So now I can think of transporting that from that location then to the market where it needs to be. And because it has a much higher value, it makes economical sense as well to do that. So there are in principle some things that could be done, but it really requires a rethinking also in sort of the whole logistics of a chemical industry.
Yeah. And so I think that actually brings up two maybe of the questions from the Q&A that I think might be good as we get closer to wrapping up. You know, we mentioned a few registries where folks are looking to participate in an RNG market, where they might go. Are there any other additional ones beyond the ones in California or others that have been mentioned here earlier that folks should keep in mind? And are there any additional out-of-the-box uses that you'd like to see from RNG in the future, where it's maybe not active yet, but you see like, hey, this could make a real difference there?
I can answer this one. So I think outside of the mandatory markets where we have LCFS and the other, you know, state-run programs, mrex, that's M-RETS, is the leading tracking system for RNG, and that's increasingly being linked up between some of these programs. And they're also big on the renewable electricity side. So good organization there. And then on uses that we see, you know, outside of the traditional biomethane in the pipeline market. So biogas and RNG can be used to generate renewable hydrogen, electricity, and sustainable aviation fuel and other projects. So I think that that's a big thing that we're looking at. We certainly have built that into our advocacy and our programming throughout our industry in our education efforts.
And I could add to what Sam said. The voluntary greenie standard is something that I think even individuals can participate in. And if they wanted to buy credits that are from RNG to reduce their carbon, their individual carbon footprint. So, and Marc may know more about this, but there are quite a few, I guess, voluntary type organizations that are looking for reductions of their carbon footprints, where you would use RNG.
Yeah, Chris, let me just add real quick. Just I always like to make this point when there's an audience, because there's a role for everybody to play here, not just us around the table. The best use for RNG is none, in my opinion. And sort of my challenge to the entire audience is put us out of business. Put Sharon out of business by not loading landfills. Put me out of business by not throwing away 40% of the food that we produce, which is the source from which I generate methane. So of all the things we can do to perfect our technology and make these investments, which is a lot of fun, and we need to be doing this, one of the biggest drivers to reducing methane sources is consumer behavior. And we all have a massive role to play in that. So I just didn't want to leave here without making that point.
Oh, my timing is horrible on that, because I was going to ask Marc, you and Sharon, just we had a late question in from Aaron around timescale. So for those that are interested in starting up this, to the extent that they haven't put either of you out of business, from ending food waste or otherwise, we've talked about the infrastructure and how expensive that can be, but assuming it's for a drop-in infrastructure of some existing pipelines, how quickly might someone be able to get participating with renewable natural gas?
So from a purchasing standpoint, if somebody's interested in purchasing RNG, it typically takes a few months to put a purchase agreement together. If somebody's interested in developing a business to capture RNG, from start to finish, you're probably looking at 24 months. And some of that is rooted in supply chain issues that we're all suffering from globally at the moment. And the other is the complexity of connecting two very different mindsets, cultures around a table to put together a transaction. You're dealing on the one end with a farmer that doesn't understand methane. They understand milking cows, as an example, or canning vegetables or harvesting beans. And on the other side, you've got a Mercedes-Benz and a Duke with highly sophisticated, well-educated folks who are doing carbon accounting. So being able to put that together is not trivial, which is why Sam's organization is incredibly important to set standards in the industry that make this a more transactable source of energy long-term.
Perfect. Thanks, Marc. Before closing out with our closing questions, Professor, to you and to Larry around, again, things you'd like to see R&D be used for, I did have one further more technical question, which might be best for either of you, but again, anyone from the panel. Jay was asking if the recovery of methane ever generates NOx.
Not the recovery, but compression. NOx is another thing that PTAC is looking at, and it's created with high temperature, high pressure. So it's not normally generated with getting methane either through production or distribution, but through compression is where you'll get it. So when you compress it to move it across state lines and stuff like that, that's where you'll end up with compressors that are at high temperature that are generating NOx's. And in your automobile engines, you get that as well. That's why we have those catalytic converters.
And you do have NOx production from burning the off gas. When you clean up methane, you have to burn the off gas, and in either thermal oxidizers or flares, you will generate some NOx.
Perfect. Thank you for that. And so back to our closing question, for Larry, for you, and for Professor, are there any novel new ways that you would like to see RNG be applied that it's not currently in there? I know that there are often lots of innovators who are listening to this, lots of soon-to-be entrepreneurs looking for a problem to solve, or students or faculty looking for things to research. Where should they be focusing their time?
From my perspective, Sam already mentioned that in order to really use it as a carbon negative fuel, again, making renewable hydrogen from renewable natural gas would be a perfect solution. Again, run through pyrolysis, capture the carbon, very easy, very efficient way of capturing carbon, much better than a post-combustion capture. And then use the hydrogen to run a hydrogen fuel cell, for example, and generate electricity, or many of the other uses for hydrogen that we have right now. I think that is one way how, it's obviously a way that already the fossil fuel industry is trying to move in some areas. That would make fossil fuels carbon neutral, but for renewable natural gas, obviously now you would actually become carbon negative. So really decarbonizing. I think that is the direction where renewable natural gas then could have a long-term impact. That would be my dream.
The researchers that we're involved with, most of them are involved with detection and measurement. So that's where I think most of the students are working. For the clean tech companies that are developing technologies, they're more in the space of like the guys that are burning methane for generating power. If you're hooked up to the power grid, you could sell that power. Otherwise, you're using it for mining cryptocurrencies or something else. Combustors, there's electronic pneumatics. Pneumatics are used for safe operations. Most of them are powered, if you're remote, by natural gas, the pressure, and every time they cycle, they vent a little bit of methane. You can replace those with electricals if you're connected to the grid, or if you put up solar panels with batteries and stuff like that to run them as well. So there's a lot of work going on that. There's a bunch of work being done for novel chemical injection pumps. Chemicals are injected for safety as well. And so those pumps are being converted to electrical. So those are the things I think that are most important right now. I put up a link in the chat box to a document that we put together for a whole bunch of technologies that are available for use, and they'd be for either new gas or old gas for oil and gas facilities, but they're suitable for collecting any sort of methane that's being emitted.
Perfect, thank you. And I was just about to close that. We got one more question that came in from Larry. So, and on the note of innovation, innovation often takes funding. So to the extent, I know Aaron's question was around DARPA funding. So I don't know if anyone knows anything about that for RNG or where folks should be following up on that front.
Yeah, we've got
in general.
Yeah, we put out calls quite regularly for new technologies and stuff. So those get evaluated and then they're funded. It's not like a prize. We had a CO2 challenge that went through X Prize. That was awarded here, I think about a year ago. That was by a bunch of Canadian companies putting together money, and actually US companies as well. And the ones that won that were to sequester CO2 into cement. There was one from, I think, California and one from Nova Scotia that won those prizes. And that's to mix CO2 into cement, and then it gets locked up with the cement.
Brilliant. All right, well, being mindful of time and trying to create more of those human buffers that we all need between our meetings that start at the top of the hour, would love to make sure that we leave a little bit of space for everyone to get off to their 1 o'clock. Thank you again to the Scott Institute for teaming up together and organizing this with the Center for Sustainable Business. We're very appreciative of the opportunity. Excited for more such to come. And thank you to each of our panelists. We're excited for you to come and share your experience with us, to have these candid, constructive conversations. I love that far more than a panel of folks who just nod and agree and build and not fun. So I appreciate the discourse that we've had here today and all of the questions from the audience and the pushes and the nudges to try and figure out, hey, how do we, in good spirit, find ways to put Sharon and Marc out of business because we've moved the needle forward on everything. So without further ado, thank everyone for the time today. And Caitlin and Kristen, I think we can call it a close. Thanks all.
Thank you.